Sherlock Holmes and Dr. Watson went camping. As they lay down, Holmes said, "Watson, look up in the sky and tell me what you see." Watson said, "I see millions and millions of stars." Holmes said, "Well, what does that tell you?" Watson said, "Well, astronomically, it tells me that there are millions of galaxies and billions of planets. Meteorologically, it tells me that we'll have a beautiful day tomorrow. What does it tell you?" Holmes said, "It tells me someone stole our tent." And so today we are starting our logic and reasoning chapter, and we're going to start with inductive reasoning. Now, what is inductive reasoning? Inductive reasoning is a process of reasoning that a rule or statement is true because specific cases are true. The most important thing to remember about inductive reasoning is that it is based on observation. You see a lot of things and you say, "Oh, that seems to happen every time." There's a really cute video where they keep throwing this potato at a guy and he says, "Ow," every time. So they figure, well, anytime I throw a potato at the guy, he's going to say "ow." And that is inductive reasoning. The statement that he's going to say "ow" is what we call a conjecture. It's a statement that you believe to be true based on inductive reasoning. So you see the pattern and you believe it's true. Conjectures may be true or false. Now, the way you can prove a conjecture is false is by giving a counterexample. A counterexample is a specific case that shows it's false. For example, the guy we throw the potato at, let's say he's really tough one day and he doesn't say "ow." That would be our showing that our conjecture is false. You only need one instance to show that a conjecture is false, one counterexample. So the process of inductive reasoning, and here we're talking about coming up with a conjecture. Step one, you want to look for a pattern. Now, I'm not telling you to throw potatoes at everybody, but observation. Then you want to list at least 3 examples if you can. And if using numbers, try setting up a table. Tables can be very helpful for algebraic patterns. Or you might draw a picture. We'll see a lot of geometric patterns where we look at polygons or the way dots are lined up. The second step is to make a conjecture based on the pattern. So you can say, aha, this is related to that by that. So what do you think is true based on the pattern? So in my previous example, we think it's true that the person is going to say "ow" every time we throw a potato at him. Now, how do we prove the conjecture? So we need to either prove the conjecture or we can find a counterexample. Counterexamples are really great ways of proving a conjecture is not true. So if we want to prove it, we're going to try using numbers, using more than one type of number, like whole numbers, fractions, positive or zero. Try drawing some pictures. You only need one counterexample again to prove something is false. So here's an example that I have. The product of an even number and an odd number is blank. So I'm trying to come up with a conjecture and see if I can find a pattern. So right now I'm just going to go ahead and come up with an even number. We'll say 2. And an odd number, we'll start with 3. I got 6. Come up with any other even number. We'll try 8, 7, 56. All right. Another even number. We'll try 6 this time. And 4. Oops, it has to be odd. 5. It's 30. What do we notice about all of these products? Well, part of the hint was we were talking about evens and odds. Did I always get an even or an odd in this example? I always got an even number. Now, there actually is a way to prove this using deductive reasoning, but we haven't gotten to that part yet. Now, let's determine if the following conjecture is true or false. So this is not a mathematical one. This is just an example. We're saying all birds fly. Well, we can think of this bird. He seems to be flying. How about this bird? Definitely flying. So far, it seems that my conjecture is true. But what about that bird? He doesn't fly. So this conjecture is false.